Okay, what about terminal velocity and maximum accelerations? Let's take a look. A particle P moves in a straight line such that distance S is modeled as follows. Okay? Determine the time at which P is moving at minimum velocity. So that's down here. Right. Things to note is, if this is the function at which the distance, right? So this is 0.4 t cubed minus right? What did we say before? The gradient is the velocity. Okay? So we're just going to differentiate that. That's just going to be 1.2 t squared minus 0.6 t minus 1.8. Yeah, cool. Now, at the point at which this is the minimum point, okay, the acceleration is equal to 0, okay? Which means we have to differentiate again. The acceleration is the gradient function of the velocity. So therefore, the acceleration is dv by dt, which is 2.4 t square, 2.4 t, right, minus 0.6, okay? That's the acceleration function. We also know that it's equal to 0. So, how are we going to work out what t is? We're just going to add 0.6 to each side. So, 2.4t is equal to 0.6. And so, t is equal to 0.6 over 2.4, which is equal to a quarter. Okay? So, when t is 0.25, it's moving at minimum velocity. Now, find the displacement from P to O within this time. What we need to do is we need to find, when t equals 0, what is the displacement. So first things first, when t equals 0, s is equal to 0.4 times 0, minus 0.3 times 0, minus 1.8 times 0, plus 5, which is equal to 5 meters, okay? What about if s is equal to a quarter? When s is equal to a quarter, s is equal to 0.4 times a quarter cubed minus 0.3 times a quarter squared minus 1.8 times a quarter plus 5. Okay? So if you plug that into your calculators, you should get an answer of 5 meters and minus, and this is the important thing, we're displacing 0.4625 meters. That is our final answer for part B. What's our velocity going to be at this time? Well, we know that the velocity is equal to 1.2 t squared minus 0. What? That. Okay, it's going to be that. So what we're going to do is just plug in a quarter during this time. So I'll write it in purple so that you guys can see. V is going to be 1.2 times a quarter squared minus 0.6 times a quarter minus 1.8, and if you plug that into your calculators, you will get the correct answer of minus 1.875. Okay? And that is your minimum velocity. Did that explanation make sense to you? Well, make sure you subscribe so you never miss another explanation from me again. Now let's take a look at this one. A particle P moves along the x-axis. Its velocity v in the positive x direction at any given time is that function. So show that P never comes to rest. Well, when P is at rest, right? What do we know about that? V is equal to 0. So what we need to do is we need to look at the discriminant, which is equal to b squared minus 4ac. B squared minus 4ac is minus 3 squared minus 4 times 2 times 5, which is minus 9 minus 4 times 2 is 8. 8 times 5, 9 minus 40, minus 31. Because the discriminant is negative, right, there are no solutions for V is equal to, sorry, that was terrible, for V is equal to 0, okay? And if we look at the graph, it will look something like this. So how will we find the minimum velocity of P? What did we say about the minimum velocity? At V min, right, we're told that acceleration is equal to 0. So the acceleration function is just dv by dt, which is 4t minus 3, which is equal to 0. So therefore, t is equal to 3/4. So now all we need to do is plug 3/4 into this, and we get our max V value as V is equal to 2 times 3/4 squared minus 3 times 3/4 plus 5. And if you plug that into your calculators, you get an answer of 3.875 meters per second. And that is your final answer. Still gibberish to you guys? No worries, you can join my Discord server and ask me whatever questions you want for fast responses. Now let's look at this question. A particle P starts at the origin at time equals 0 and moves along the x-axis. At time t seconds, the distance of the particle is given as this function. What would the displacement time graph look like for that? Well, let's have a sketch. It's a cubic, and we also know that there's no y-intercept, so it's gonna look something like... It's gonna start at 0, 100%. Maybe something like this. Yeah, something like that. Okay, if we're also looking at on that side. Sure. So, justify the restriction of 0 to 4.5 seconds. From 0 to 4.5 seconds, it looks like that's the point at which we go negative. So it's not going to look like this. Or rather it is. And this is 4.5 seconds. And anything low, you have a negative displacement. Right, this is your displacement, this is your time. Okay? Alright, if this is true, how are we going to find the maximum distance away from particle O? The way we find it is, first things first, we need to work out what the velocity is. Because at the maximum displacement, it's at rest. Okay? Which means that if s is equal to 9 over 2 t squared minus t cubed, the velocity is going to be ds by dt, which is equal to 9t minus 2t squared. And we know that it's stationary at the point of max. Through symmetry, I know that this is 2.25, but in case you don't believe me, we're going to factorize t out of this. So t, and this will be 9 minus 2t, which is equal to 0. And so therefore, t is equal to... Sorry, it's 3. It's 3t. Should be 3t. Squared. There you go. 3t squared. 3t squared. Anyways, t should be equal to 0 or 3. Okay, maybe I was wrong about that. Of course I'm wrong about that, because this is a cubic, not a quadratic. Yeah, it's going to look something like this. We've already discussed this. Everyone makes mistakes. That's okay. Right, anyways. Now that we know that t is 3, okay, correctly, rather than 2.25, let's plug that into s. So s is going to be 9 over 2 times 3 squared minus 3 cubed, which is equal to 13.5 meters. And that is your final answer. What about the acceleration of the particle at this point? Well, if this is the velocity, 19 minus 3t squared, right? The acceleration is just going to be dv by dt, which is equal to 9 minus 6t. We know that t is equal to 3, so the acceleration is just going to be 9 minus 6 times 3, which is equal to minus 9 meters per second squared. And that is another 3 marks that you can get for this question. Thank you guys for watching. Do you guys want to pass your exams with flying colours? Well, you can get tutored by me yourself. Drop me an email and we can organise a meeting. Keep on learning, as you have no idea what you're capable of doing.